This is R.D. Sharma solution, class 12, chapter 19. Exercise is 19.29 and we are taking indefinite integrals. So we have done question like this. You have understood the methodology, the process. So under root x square minus a square will be used. That's why I showed this expression. Let us call this as I, and 4x plus 1, which is the linear equation, which is outside of the root, and there is a quadratic equation inside the root. So 4x plus 1 has to be represented in the form of differentiation of x square minus x minus 2, and the differentiation will not be equal. That's why we need to include lambda and mu. These are certain symbols which we are using. You can use any symbol, and these are being employed just because 4x plus 1 will not be equal to directly differentiation of x square minus x minus 2. Now let's do the differentiation. D by dx, or differentiation of x square minus x minus 2, is 2x minus 1. Now let's multiply this inside and try to evaluate or equate the similar term. That is 4x plus 1 is equal to 2 lambda x plus mu minus lambda. So this 4x will be equal to 2 lambda x, and this mu minus lambda will be equal to 1. So here you get lambda equals to 2 from the first equation after equating the similar terms. When lambda is equal to 2, mu is going to be equal to what? It will be 3. Now this equation number 1, we have to replace lambda and mu by 2 and 3 respectively. When we do this, then we get the 4x plus 1 ready to be replaced in the original equation I. So I'm replacing or changing lambda as 2 and mu as 3, which we just computed, and this particular equation we just found can be, now this equation number 2 can be a part of original equation, and this will make our integration easier. So integration will be 2 into 2x minus 1 plus 3. It is essentially 4x plus 1 only. So 2 multiplied by 2x minus 1 plus 3. Then we have under root of x square minus x minus 2. So this is integration. This is dx. So let's multiply this inside. So I'm taking 2 outside. So 2x minus 1. And then we have under root x square minus x minus 2. Then we have 3. So multiply 3 by under root x square minus x minus 2. So we have got two separate terms which we actually intentionally try to divide, because now the integration will be in two parts, and that will make integration easier. That is I1 and I2. If we call this, I1 is direct. X square minus x minus 2, if we call it as f, x, 2x minus 1 will be equal to f dash x. So it's simply the differentiation of fx. So if you take the power of fx, which is half in this case, so the direct result of integration of f dash x, that is the differentiation of fx, and fx is raised to certain power n, then the integration will be directly fx to the power n plus 1 divided by n plus 1. And n is half here. Fx is x square minus x minus 2 in our case. I am only talking about I1 right. So 2 was already there. X square minus x minus 2 to the power 3 by 2 is there. And in the denominator it will be n plus 1, which is again 3 by 2. Now it goes up 2 by 3, so it will be 4 by 3 x square minus x minus 2 raised to the power 3 by 2. So the first part, which is the I1, we have already computed now. It will be 4 by 3 x square minus x minus 2 raised to the power 3 by 2. So the next step is to find out the I2, and we'll combine it with I1, and that will be our final result. So I2 is 3 I have taken outside, it's a constant. Under root x square minus x minus 2, which is a quadratic equation, can easily be converted into a perfect square. So x square minus x minus 2, you have the middle term in front of x is a constant, which is 1. We divide it by 2, square it, add it, subtract it. So I'm adding and subtracting this half square. So a square plus b square minus 2ab, which is x minus half whole square, is the first term. How about the second term? That is negative 2 minus 1 by 2 whole square. So it's just 2 plus 1 by 4. You can take negative outside. It will be simply 2 plus 1 by 4, which is 4 to the 8. 8 plus 1, 9. 9 by 4. 8 plus 1 by 4 is 9 by 4, which is essentially 3 by 2 whole square. We need a perfect square. That's why I have written 3 by 2 whole square in place of 9 by 4. And this negative was taken outside, if you remember. So it's not positive, it's negative. So x minus half whole square minus 3 by 2 whole square. Now under root x square minus a square formula is already being projected in front of you. You can use or employ this formula and use the direct result. So we are actually integrating under root x minus half whole square minus 3 by 2 whole square. In this case, x will be taken as x minus half, and a will be taken as 3 by 2. So we'll deal with this 3 later. X by 2. So x minus half divided by 2 under root of x square minus a square, which is essentially x square minus x minus 2 only. This is x square minus x minus 2. Then you have a negative a square by 2. What is a? 3 by 2. So 3 by 2 whole square is 9 by 4. And then we have a 2 in the denominator as well. Log modulus of x is x minus half, plus under root, and same thing will come, x square minus x minus 2. Now constant of integration will combine from I1 and I2 and call it as a common constant of integration. X minus half is simply 2x minus 1 divided by 2. You have a denominator already as 2 and 3 is multiplied. So 3 multiplied by 2x minus 1 by 2, and there is a 1 also in there. There is a 2 also in the denominator. So we'll get 3 by 4 2x minus 1, and then under root of x square minus x minus 2 is already there. What is the second term? Which is 3 into 3 by 2 whole square by 2. So I just left or forgot to write under root x square minus x minus 2. Just imagine that it is already there. Now coming to the second part, which is 27 by 8 log 2x minus 1 by 2. You can just keep it like x minus half only. It doesn't matter. Under root x square minus x minus 2 in modulus. Now I'm just adding I1 here. Please remember that I just missed under root x square minus x minus 2 in this term, 3 by 4 into 2x minus 1. So assume that it is multiplied by under root x square minus x minus 1. Now I am including 4 by 3 x square minus x minus 2 to the power 3 by 2, which is the first term, which is I1. So I1 plus I2. Now let me give you the exact solution, and whatever I have done is projected here, and this is the actual solution which you see here. So 3 by 4 2x minus 1 multiplied by x square minus x minus 2, which you need to note, and formula has to be under root x square minus a square, that you need to utilize and remember. So all the questions are almost similar. So we have x minus 2 outside, which is linear equation, under root x 2x square minus 6x plus 5, which is the quadratic equation. And this is how you can solve it, because we have done a question like this. 2 or 3 questions we have already completed like this. So this is for your reference only. Now since we have all plus here, so I don't think that you will have any problem. If you understood the first or second or third question, then there are questions coming up like this only. So I'll try to do that, but I'm just leaving it for you and trying to show you the reference. So 2x plus 3 under root x square plus 4x plus 3. Now just we have seen the question number 7. It also has all pluses, but you'll see a change here. So linear equation will be represented by the differentiation of the quadratic equation. 2x plus 3 has to be equal to d by dx of x square plus 4x plus 3, but it will not be equal because it will be only 2x plus 4 after differentiation. So you need to have a lambda in front of this d by dx. You need to add some mu, that is lambda and mu are the constant, in order to make the right hand side equal to the left hand side. So 2x plus 4 is the differentiation of x square plus 4x plus 3, which has a lambda in front and mu added. So let's multiply this inside so that we can equate it with the similar term on the left hand side. 2x lambda plus 4 lambda plus mu. You have 2x plus 3 on the left hand side, so you can equate 2x with the 2x lambda. So 2x along with 2x lambda, then we have 3 equals to 4 lambda plus mu. Now I just cancel this, 2 to cancel, lambda equals to 1 from the first equation after similar terms with x has been equated. Now constant term has been equated, which is 4 lambda plus mu equals to 3. Replacing lambda by 1, you get mu equals to negative 1. So in this equation number 1, just change lambda by 1, mu by negative 1, and then you get a 2x plus 3, which is quite comprehensible and can be put in the equation so that we get a proper, easier integration result. So 2x plus 3 I'm writing as a result, which we have done. 1 into 2x plus 4, negative 1 or minus 1. So this, don't remove this 1 in front of 2x plus 4. You'll see just now. So 2x plus 3 can be represented because integration is the whole expression. It's 1 into 2x plus 4 and minus 1. So this is just 2x plus 3. And this is followed by under root x square plus 4x plus 3. So x square plus 4x plus 3 has to be multiplied by these two terms. Don't try to make 2x plus 4 minus 1 as 2x plus 3 because it is essentially that. But we have done all the effort just to relieve get an idea to integrate it easily. So 2x plus 4 into under root x square plus 4x plus 3 is the first multiplication, then the negative is multiplied by under root x square plus 4x plus 3. Now you know that integration of f dash x, fx to the power n, is fx to the power n plus 1 divided by n plus 1. This is a direct result which we can employ in the first part. We call it as I1. Under root x is simply x to the power half. So we have n equals to half here. So 2x plus 4 is the direct differentiation of x square plus 4x plus 3. So I1 will be equal to x square plus 4x plus 3, and this raised to the power 3 by 2 because n plus 1 by 2 plus 1 is 3 by 2, and divided by n plus 1, which is again 3 by 2. It goes up and it will become 2 by 3. And then you have a, see, please remember it is negative also. Now this is I2. Let's call it as I2. We are integrating under root x square plus 4x plus 3. So under root x square plus 4x plus 3, what is the coefficient of x, which is 4? Divided by 2, you'll get 2. Square it, add it, subtract it. So we are adding and subtracting 4 in this expression, a quadratic equation. So x square plus 4x plus 3 plus 4 minus 4. So x square plus 4x plus 4 is x plus 2 whole square. A square plus b square plus 2ab. So x plus 2 whole square is this one, and 3 minus 4 is negative 1. So you can call it as a negative half square. And this is integration. So we have x square minus a square. Now this is inside a root. So x will be taken as x plus 2. A will be taken as 1. I just missed the under root. Just imagine there is already a root, because we are actually essentially taking the integration of under root x square minus a square. So under root x square minus a square is x plus 2 by 2. Then under root x square minus a square is x square plus 4x plus 3 minus a square by 2, which is 1 only, 1 by 2. And then we have log modulus of x plus 2 plus under root x square minus a square, which is essentially x square plus 4x plus 3 only. Original thing. So under root x square plus 4x plus 3. Now there will be a constant of integration from I1. There will be a constant of integration from I2. Let's combine this, and final will be a constant C, capital C. Just call it as capital C. So I will be equal to I1 plus I2, which is x, which is first one is 2 by 3, x square plus 4x plus 3 to the power 3 by 2. And since it is negative, because we are dealing with negative here, so the sign is going to change. So minus x plus 2 divided by 2 under root of x square plus 4x plus 3. And then we have third term, minus minus will become, it will become plus, of course. So it will be plus log modulus of x plus 2 plus under root x square plus 4x plus 3. And this is a constant of integration. And there is one thing that I2 is actually under root x square plus 2 whole square plus 2. Please remember that, minus 2. So this is what the whole idea is. I hope you'll be able to do this. Okay. Now in this plus also, you have encountered under root x square minus a square. So the formula has to be learned by heart, because it will be used all through this exercise. This we'll discuss later. Thank you so much. Have a good one.